Okay, thanks very much. Sometimes you get called an expert or a guru and things like that, but those terms come along pretty easily sometimes. You just have to stay in the same area for a good number of years, and that doesn't happen so much these days. But I have been in this area of soil acidity and have been able to observe things, and that's some of the things that I want to share with you today in terms of what have we learnt, make sure that we don't go reinventing the wheel, and make sure that we can move forward, because as you've heard over the last day and or yesterday and then today as well, many of the projects and many of the things that we're talking about are recognising the importance of pH as a component of what they're doing. So I thought a way to start off might be to give a comparison of the way I saw things, and I'd probably just like to point out, well, just go back and acknowledge my authors there, my co-authors. Yvette from CSIRO, James Fisher from Desiree Futures, Joel Andrew and Stephen Carr from Precision Soil Tech. Now, in so much as this presentation diverges a little bit from the paper, then any faults or anything I willingly accept as my own and my own interpretations. So, as I said, I'll start off with a comparison of the way I saw things in 1994 when I started in this area, to the way I think we see them at the moment. So we knew that agriculture needs lime. That was a given back then, and it's a definite now. Nothing's changed. If we look at understanding the current status, we had a good understanding in certain areas of the levels of pH and what was likely to happen to them. And through the work that we've done since the mid-2000s, we now have a very good understanding of the current situation, and I'll flick that up in a few slides' time. We predicted that things would continue to acidify and that we would be in a situation where lime was needing to be used, or we'd be having yield losses. That's the same, and the work that Yvette has done on a lot of our lime trials that we've gathered together, and I'll go through those as well, shows that 10% is a common long-term average in terms of yield response, and how we get that. And in other circumstances, that yield can be much more. And again, I'll just emphasise that means that we're losing yield in that respect. Okay, we've heard a lot, and we continue to hear a lot about quick fixes, about incorporation of lime and mixing that into the surface and into the subsurface, and what's the best way to make that happen, and how can we achieve these gains. Back in 1994, actually, we didn't even think about that as a concept. It wasn't really necessary. We'd have been liming at the rates sort of recommended back then. We'd have been very close to maintenance rates, and probably would have adjusted things on the way through, and lime use would have gone up a little bit, and we wouldn't have seen some of the situations that we see now. And I'll give an example of a trial at the end of my talk that demonstrates that. But now we're certainly looking at ways of getting the lime incorporated and into the profile. That change could take a generation. Well, I guess I was new to the game then. It was the first time we'd sort of tried changing farming systems and things like that. And to me, the trial results early on were showing that, you know, the benefits were there. So I didn't really even think that change would take as long as what it has. But I'm pleased to hear from John this morning, and you know, lime use is going out at an all-time record this year, and we need to keep that. That'll pose its own problems, but we'll get on with that. And again, this need to target lime application. So farmers with limited budgets are accepting the need to use lime and are increasing their lime use. What we need to make sure now is they've got the knowledge and the information to actually make the best value use of that lime that's going on, and get the changes and the results that they're after. So, to cover off on agriculture needs lime, we started off in 1994 or the early 1990s with 1 tonne every 10 years as a catch cry. It was probably a little bit low in terms of its actual rates, but it was a good place to start, and we called it the Time to Lime campaign, which many of the older people will remember, and some others perhaps not yet. Then a bit later on, sort of in the early 2000s, mid-2000s, we had Time to Relime campaign, so capitalising on the information that was given out earlier, and we upped the rates to sort of 1 to 1.5 tonnes. And now, this is an unofficial logo, but maybe we're running out of time to lime. A lot of people really need to start thinking about getting the measurements of what their soils are. And we're actually having good evidence that, you know, almost if you haven't been putting any lime on, don't start with anything less than 2 tonnes to the hectare. Of course, you know, site specific and that sort of caveat, but we're seeing that up to 8 tonnes over the last 20 years is a rate that has managed to lift and maintain a soil profile. So some work that I did put up last year, but I thought was worth putting up quickly as a refresher on this the report card that we did with the department and using the results from our collaborative projects with Precision Soil Tech and farmer sourced pH measurements from all over the state. We can see that in the topsoil that between 70 or about 70% on average over the whole lot, but you know, much of that area shaded dark shows that 75 to 100% of thousands of samples from these areas that have been collected over the last 5 or 6 years are below our pH target in the surface of 5.5. We use that target to make sure that lime moves down the profile and treats the subsurface. And we can see that 50% there of the 10 to 20 centimetre layers are below our pH target of 4.8. So when you get below that target, the sensitive crops start losing yield, and below 4.5, then even the tolerant crops start losing yield as well, mainly through reduced access to moisture and nutrients. So that's for the 10 to 20 centimetre layer and also for the 20 to 30 centimetre layer. So you can see it's a widespread problem. It broadly picks out the soil type. So we do have acid, sandy soils in these sort of areas at depth, developing certainly through the sort of central West Midlands area, and then we've got the different soil types shown by the lakes and down in salmon gums. So the information is there on a wide scale sort of basis, but individually farmers need to respond to what's in their actual paddocks. Now to go on to some of the work that Yvette has done using lots of our long-term trials and other trials where we have good data sets of pH and yield responses over time. A total of 69 trials, and many of them have run for many years as well, so there's a huge amount of data there to work from, covering all crops and all seasons, so we haven't separated that out. And you can see the geographical distribution there across the state, and that's not all of the trials, but it shows a widespread. What Yvette's been able to do is take all of those and look at whatever was the maximum yield across those trials and compare it to where the yield in the trials with zero lime. So the black line is the one-to-one line, so anything below the line is a larger response or a response to lime. We're getting more maximum yield or greater yield here than compared with the unlimed profiles. Now a lot of stuff goes into the mix here. It's sort of a warts and all analysis, but what we can see is when we get up to the high rates of maximum yield, there's not much deviation from that one-to-one line. So we can assume that we haven't really got much in the way of constraints, and acidity is unlikely to be one of them. Similarly, down at the very low end of the yields, there's not too much deviation away from the line, and what that means is that there are probably multiple constraints, and just fixing acidity is not going to give you the benefits that you would be looking at or would be after. But somewhere through the middle, where we've got moderate yields, there's a fairly consistent sort of 10% deviation from that line. And again, if we look at after lime in these trials has been on for 2 or more years, and there's probably another caveat to come there, but if we're in this data set where the lime has been on for 2 or more years and started to work, then that yield response is across the board about 2.5 or 250 kilos, or about 12%. So long-term averages, that's the way it sort of is looking. And Yvette's been able to model similar stuff to that using APSIM, where by applying a root hospitality factor, if you like, or so the higher the number there, the less constrained the roots are in the model in terms of root growth. So we can see that the deviation is less from the line. Where we apply a severe constraint, then obviously overcoming that constraint gives you a much bigger yield response. I guess what's interesting is that, you know, all of our sites fall somewhere in these areas, and what it shows is that there's 100 different years, 100 different seasons, and that's the thing that gives the variability. So the actual impact of soil acidity, and particularly subsurface acidity, is highly related to the demand for deep water. And last year in 2013, in a lot of cases, we didn't see the sort of detrimental effects that we might have expected from subsurface acidity, and that's because we had a kind finish over much of the area. You know, rain that continued through September and allowed the crops to benefit from that, from surface water. So how do we understand this yield increase? The next couple of slides show when I would expect to see a yield increase and perhaps when I wouldn't expect to see a yield increase. Sorry for everyone over there, I keep on pointing over to this side, but that's what they requested I did. We see a yield increase, obviously, when we've overcome the constraint, when we've put enough lime on and it's been on for enough time to actually change the pH and remove that subsurface constraint. And if we do that, here's an example from Kalani in barley, a sensitive species. Whoops. So subsoil pH 4.6, that's just above the critical. We had quite a large barley crop just a few metres away from it, pH 4 in the subsurface and pH 3.8, and just a dramatic effect of that, of those treatments. So obviously we'd expect to see a yield response when, or a greater yield response when we have a sensitive crop that's grown on that area. So on responses to liming, I think it's important that we think about when we wouldn't have a yield response, and obviously we wouldn't expect to see a yield response if pH is not a constraint to what's going on, just as if you've got a phosphorus trial in a paddock where there's plenty of phosphorus in the soil, then we wouldn't expect to see a response. The other times when we'd expect to see one is as I've just explained, is if the paddock yield is very low, where you're likely to have multiple constraints, or if the paddock yield is very high, where you're likely not to have yield constraints. Yeah, in terms of low and high, I mean in relation to the yield potential of that paddock. So if the potential is only 1 tonne and you're getting close to that, then it's unlikely we're going to get a response. Similarly, if it's higher and you're getting close to that as well. So I'll come back to this insufficient time, and this is probably something that people need to be really aware of, is has there been enough time and has there been enough lime applied to treat those constraints? And people often think that, you know, they put 1 or 2 tonnes out over the last 20 years, and that's not really generally enough in terms of the rates of acidification that we're looking at, and people need to measure it. So there are a few factors in there in terms of the amount, so just the raw quantity, but to go with that quantity of lime that's being applied, what is the quality of it, the neutralising value, because that's important, that dictates the capacity of the lime to change pH, and then the time is what goes on, is how long has it had time to react, or if we've actually done some of the mixing in, which seems to be popular more in the north at the moment. I guess we also wouldn't expect to see a response if we've got a very tolerant crop. So lupins are very tolerant to acidity and generally don't respond to liming. So I think all the evidence is, from the work that Yvette's done looking at our work, out of the trials and everything, is that lime does work. And probably take-home message from the last couple of slides is usually when someone tells me that lime doesn't work, or they put in a report that lime doesn't work, they probably haven't taken proper account of some of those factors there. And when you are assessing some of these reports and some of the short-term trials, that would be my, I guess, my flag to you to make sure we have a look. Okay, I'm not sure how well this shows up. Last year I was fortunate enough to get called up and made aware of some responses in a paddock in a trial that we started in 1994, and hopefully you can see here some pretty startling plots. These are 2 metre wide plots, 40 metres long, and 4 replicates in that area, and some other trials here that showed the same. It's where we applied 0, 1, 2 or 4 tonnes of lime back in 1994, and I was fortunate enough to get taken up and have a look at it. A pretty startling visual response there, and that stimulated us to go out and have a look at the trial, and Stuart Smart and Kim Flay were happy for us to go and bash around in their crop there. Now they'd managed this crop for 10 years since we'd done anything on it. They've also applied an extra 4 tonnes to the hectare over the whole lot. So we're looking at 4 tonne as the lowest rate, up to 8 tonnes at the highest rate in this trial. So I want to draw your attention to what the pH was when we started in 1994. Just below 5.5, down below just below 4.5, a little bit lower, and that was as deep as we measured in that period of time. You can see where we've added either none, 1 or 2 tonnes, that down here the pH has continued to acidify, and not only is the pH lower, as in 4 now, it's also that minimum is deeper. And I'll come back to the green line in a moment, but I'd just like to point out in the theme of the talk, going back to 1994, that this is not the first time that we've actually seen this. Perry Doling and Bill Porter published some work here looking at natural bush and did comparisons to after farming after 12 years, after 50 years, and after 74 years. And we can see a decrease in pH through that bulge, and also the pH is decreasing lower down the profile. So I guess that's what we knew was going to happen, and in the light of this trial and the samples that we took in 2013, we've actually seen it happen. And that's, I guess, one of the advantages, or you might say disadvantages, of hanging around in the same area for a good number of years. The benefit though, where we applied 4 tonnes back in 1994, and in the last 10 years farmers have applied another 4 tonnes, we're now looking at this green line which sits up with the thumb's too big. Sits up above 5.5, almost up to 6. Now remember, that's had all the last lot of farmer 4 tonnes, so all these rates looking pretty similar up at this level. The big difference occurs as we go down through the profile, and at 30 to 40 centimetres we're just still above our sort of 4.5 critical level. So this is still requiring more time, and actually since the farmers' profiles now mostly look like these lines here, they're actually doing a massive moldboarding program to turn this lime into the soil. Thanks. Actually turn this lime into this depth and bring up some of this, and then reapply some more lime and get the lime onto this area here, onto what they build up. So what were those different profiles worth after all that time to grain yield at Mingenew in 2013? About 4.4 tonnes, 0, which was the farmer's 4 tonne, not a bad average for the whole paddock, and basically stepwise increase to almost half a tonne extra, where the 4 tonne and that ameliorated profile was sitting 4.85 tonnes. So they were pretty pleased when we were able to go and get those sort of measurements off those trials. This sort of responses have been happening over a good number of years. I think I'll let consultants and economists and people like that put the dollars and cents on it. I'm always a bit uncomfortable doing that, because I never know how much farmers can actually get the lime on their paddocks and how much they can actually sell their wheat crops for. So, just like to finish off now with a slide showing lime use and practice. Back in 1994, we were using about 100,000 tonnes of lime across the wheat belt, and we were estimating that about 1.1 million tonnes was required on an annual basis to treat the existing and the ongoing acidification that was happening. We've never got to the estimated requirement, so effectively over the last 20 years we've been falling behind. At the same time, we've been increasing our use of nitrogen fertilisers, we've increased our yields, as we've seen over the last couple of days with the slides that have been shown, and so we've increased our acidification rates as well. So our new assessment, with all of the information that we have on the current situation across the wheat belt, is that we need 2.5 million tonnes a year of lime over the next 10 years to treat existing and ongoing acidification, and after that we might be able to fall back into a maintenance zone. Now, we're not going to double lime use overnight, and that would bring with it its own set of problems, but I'm pleased to say that it's been a reasonably linear and perhaps even increasing beyond linear response over the last few years, that we're about 1.3 million tonnes last year, and as I mentioned at the start, John's telling me that there can be 30 odd road trains lined up still getting lime or starting to get lime at this time of year, which shows a pretty big change in practice. So I'd like to see that people were putting that lime in the right place and at the right rate so they can get the benefits. So my key messages to finish off haven't really changed a lot, I don't think. Soil tests to depth and understand the situation, that's really important, so you know where to put the lime for the most benefit. Applied at the right rate. If you're just putting 1 tonne out over to the hectare, unless you're actually in maintenance levels and putting that on every 3 or 4 years, then that's probably too low. You're going to still have an acidic soil and not be getting the benefits. And I think that in some situations now, cultivation and incorporation, and there are many projects developing and looking at that, might be what's required where subsurface acidity is severe. I'll leave it there for questions. Thank you.
Thanks, Chris. Andrew Hornick from Esperance. And Chris, we've got quite a bit of acid sand plain, obviously, along the south coast, and then we go into the transitional country where we've got shallow sand over alkaline clays. What's your opinion there, where we're getting down to that, 4.5 and lower in that shallow sand, and then going into 7s and 8s in the subsoil, and then considering that the seeding operation nowadays, we're often putting the seed down on that interface. And do we need to apply lime at that tonne and a half or whatever to address that 0 to 10 acidity?
The effect in the topsoil, and probably Craig might talk about this a little bit more, but the effect of low pH in the topsoil is generally to make nutrients less available, and certainly if you've still got legumes in the system, it will affect the functioning of the rhizobium and the nodulation and nitrogen fixation. So I think from that purpose you do need the lime in the surface. The roots and the plants are obviously going to end up with other issues dealing with pH 8 and 9 in the subsurface, boron toxicity and other things are possibilities. So you're putting the plants in a challenging environment on those sort of soils, but those would be the main limitations of if you've just got that top 10 centimetres acidity. The thing to probably remember on the south coast in terms of looking at rates and things is to understand what the neutralising value of some of those lime supplies are, because they're not as high just because of circumstance and geology as the lime sources once you move north of Perth. And I'm generally talking, when I talk rates, I generally think high neutralising value, so it needs to adjust for that.
Chris, Glenn Brayshaw from Plan Farm. At the moment there's a bit of criticism in regards to grain movements coming to Perth on say trucks. What's your thoughts as far as 2.5 million tonnes on trucks going back out to the wheat belt? Is that going to be an issue in the future?
Look, as I said, if we were to double lime use, and I think already with the increase in lime use at the moment, we are seeing issues, and that's something that hopefully my new project can try and help facilitate and look at, a bit out of the square. How can we move lime most efficiently and effectively? There's no reason why farmers on tramline traffic, if they've got the situation, they could be spreading lime throughout the winter. It gets an extra season of rainfall on it and that sort of stuff, that it could be spread on in crop, providing the paddocks are trafficable. So I think what will happen is that where those circumstances can be accommodated, that's what people will do. We're hearing stories that, trucking companies want to commit to delivering lime to half a dozen or 10 farmers as a job lot, if you like, rather than doing five or six loads to a particular farmer and missing out on a bigger contract. Because there's going to be issues. I think the trucks on the roads, there's nothing new I could have put up on that initial chart, a thing that said heavy lime haulage routes. They were all being developed in the early 90s. They were all being considered. Extra money was put to make some of those east-west roadways more robust, just for those circumstances. And look, people are looking at other ways, but I think at the moment, if there was a cheaper way of getting it into the farm, people would be doing it.
Chris, John Blake, Stirlingster Coast. A question on lime efficiency. When would a variable rate become appropriate? I mean, obviously in a ranked efficiency across the whole lot, that's not the big deal. And a second question is, could you comment on lime supply?
Yep. I've given a couple of talks previously about variable rating lime. If people have got the capacity to, and they've also, wanted variable rate as they go, then I think that's fine. Where you've got variable paddocks, with where pH changes in patterns and soil types change, then yes, that's exactly what I'm saying in terms of put it where it's required and don't put it where it's not. So. And I'm not saying use any less, I'm probably saying take it from where it's not going to be of a benefit and put it where it is going to be of a benefit. So from the heavier soils onto the sandy soils and up the rates is what needs to happen. Whether you need to actually do that by, a tonne here and 2 tonne here on the same spreading run, I probably tend to think that's overcomplicating things. If you need 2 tonne and 3 tonne in a paddock, I'd probably go 2 tonne over all of the stuff that needed lime, and then 2 or 3 or 4 years' time, come back and put 1 tonne over, or check again probably, and then put 1 tonne over the area that needed 3 tonnes. And that's probably just as effective as going to having something that open shuts on the way. But really whatever works is when you're up to those rates. I wouldn't go putting out 5 or 6 or 8 tonnes in one bash perhaps, depends on the circumstance and how you're going to mix or not. And in terms of lime supply, as you know, lime supply on the south coast is limited, and its quality is also not as high as in the rest of or further north of Perth. So people need to be aware of that when they're spreading out lime, because sometimes if it's a poor quality lime, they're only spreading out, when they put out a tonne of product, they're only putting out maybe 300 or 400 kilos equivalent of reactive lime. So they need to up the rates in that respect. Overall, WA is, at the moment, is well supplied with easy access lime compared to the eastern states even, and compared to lots of places in the world. But no doubt we'll be putting more pressure on those things, and there's more pressure coming. Agriculture at 1 million tonnes a year is a small user compared to mining and construction. So, and both of those industries have a lot more capacity or willingness to pay whatever's required. So I think those are more concerned than the quantity that's there at the moment. There are bigger supplies of lime at greater distances, like on the Nullarbor and further north. So at the moment, it's cheap and effective.